Imagine you are asked to solve a complex problem. And to make things even more challenging, you cannot use the tools you'd normally use to help solve the problem. Sounds pretty difficult, right? Without a strategy, it certainly would be. Today, we are going to demonstrate a common process for solving complex problems known as computational thinking. Computational thinking is the thought process involved in formulating a problem and expressing its solution in such a way that a computer, human, or machine can effectively carry it out. Computational thinking involves 4 steps. Step 1 of the computational thinking process is decomposition. Decomposition involves breaking a complex problem down into smaller, more manageable parts. For example, take this math problem. Find the sum of all numbers between 1 and 200. How can we break this problem down into smaller equations? 1 plus 2 equals 3. 3 plus 4 equals 7. 5 plus 6 equals 11. 7 plus 8 equals 15. This is going to take forever, and it's really hard to keep track of in your head. There's got to be a better way. Let's try a different set of combinations. 200 plus 1 equals 201. 199 plus 2 equals 201. 198 plus 3 equals 201, etc. Step 2 of the computational thinking process is pattern recognition. Identifying patterns or trends within a problem. Let's return to the problem we started in step 1. Find the sum of all numbers between 1 and 200. What pattern do we see here? If we take the sum of the high number and the low number, we get 201. And all the other pairs have the same sum. We need to figure out how many times the 201 pattern repeats. You could count all the pairs, which would take a long time, or take the high number and just divide it by 2. 200 divided by 2 equals 100 pairs. If the sum of each pair is 201 and we have 100 pairs, we can now determine the sum of all numbers between 1 and 200. Step 3 of the computational thinking process is abstraction. Abstraction suggests we identify specific similarities and differences among similar problems to work toward a solution. In our original problem, we had to find the sum of all numbers between 1 and 200. Let's look for similarities and differences. All the pairs have the same sum, so we can get rid of these. Now, if we focus only on the important details, we see that we can express the problem as an equation. 200 plus 1 tells us the sum of each pair. 200 divided by 2 tells us the number of pairs. Multiply them together, and we find that the sum of all numbers between 1 and 200 is 20,100. The fourth and final step of the computational thinking process is algorithm design. Algorithm design involves developing step-by-step instructions for solving the problem, which you can use again to solve similar problems. In our original problem, we had to find the sum of all numbers between 1 and 200. Step 1. Find the sum of 200 plus 1. 200 plus 1 equals 201. Step 2. Find the quotient of 200 divided by 2. 200 divided by 2 equals 100. Step 3. Multiply the answers from step 1 and step 2 together. 201 times 100 equals 20,100. This algorithm can be used to find the sum of all numbers between 1 and any number. Let's see how it works with 1,000. Erase the 200s. Now find the sum of all numbers between 1 and 1,000. 1,000 plus 1. 1,000 divided by 2. Multiply them together, and we end up with 500,500. Computational thinking can be used to solve problems that may previously have seemed impossible to solve. It is a powerful skill you can use